Let's solve some problems for exponential numbers. The first one is this. Simplify. 7 squared to the power of 3 multiplied by 7 to the power of 4 divided by 7 to the power of 9. If you look at the first term here, which is 7 squared to the power of 3, you can use the rule for power of power. That means a to the power of m to the power of n equals a to the power of mn. If you use this rule, 7 squared to the power of 3 will be 7 to the power of 6 because 2 3s are 6. That means the problem will look like this. 7 to the power of 6 multiplied by 7 to the power of 4 divided by 7 to the power of 9. Now when you multiply two numbers with the same base, what you do is you add the exponents. So let's add 6 and 4. 6 plus 4 equals 10. So the numerator is 7 to the power of 10. Now you can see that the base is the same in the numerator and the denominator. So for this division, you are going to use this rule. Subtract the exponents. So 10 minus 9 equals 1. That means the answer is 7 to the power of 1, which equals 7. So the value of this expression is 7. The next problem is this. 3 to the power of 4 multiplied by 2 to the power of 5 divided by 3 to the power of 3 multiplied by 8. If you look at the numerator, the bases are 3 and 2, and in the denominator the bases are 3 and 8. Can we do something where the bases in the numerator and in the denominator are the same? Yes. 8 equals 2 cubed. 2 2s are 4 and 4 2s are 8. So 2 cubed equals 8. So instead of 8, if I write 2 to the power of 3, it looks like this. That means the denominator is 3 cubed multiplied by 2 cubed, and the numerator remains as it is. Now what we can do is we can divide the numbers that have the same basis. That means divide 3 to the power of 4 by 3 cubed and divide 2 to the power of 5 by 2 to the power of 3. And when we divide such numbers, we subtract the exponents. So our expression equals 3 to the power of 4 minus 3 multiplied by 2 to the power of 5 minus 3. That equals 3 to the power of 1 multiplied by 2 squared. 3 to the power of 1 means 3 and 2 squared equals 4. So we get 3 multiplied by 4 and 3 4s are 12. So our answer is 12. So the answer of this expression equals 12. Let's solve one more problem. If you look at this problem, you can see that there is a variable used here. The problems you solved before had only numbers. In this problem, we have a variable. But that doesn't make any difference. Whatever method we used before, the same method is applicable here as well. So let's solve this problem. 5 to the power of 7 multiplied by a to the power of 10 divided by 25 cubed multiplied by a to the power of 6. Again, if you look at the numerator and the denominator, the bases in the numerator are 5 and a, and the bases in the denominator are 25 and a. So if we want to have the same basis in the numerator and the denominator, let's write 25 in such a way where the base is 5. 5 squared equals 25. So if we replace 25 by 5 squared, it looks like this. The numerator remains the same, and in the denominator it looks like 5 squared to the power of 3 multiplied by a to the power of 6. Now we know the rule for power of a power. So let's multiply 2 by 3. 2 3s are 6. So now the denominator looks like this. 5 to the power of 6 multiplied by a to the power of 6. The numerator remains as is. Now you can divide the numbers with the same basis, and for that we subtract the exponents. So what we get is 5 to the power of 7 minus 6 multiplied by a to the power of 10 minus 6, which equals 5 multiplied by a to the power of 4. And when you have a number and a variable, you do not need to write the sign of multiplication. So you can simply say 5a to the power of 4. So the answer is 5a to the power of 4.